are at the looking at lists. So let's look at the Einstein puzzle, basically very famous logical puzzle, right? So how we do this? It's very well suited for Prolog, the inference engine, basically, right? You've probably done this on a piece of paper, right? The riddle or zebra puzzle, right? Who owns the zebra, right? Or who owns the fish, right? Right. So Norwegian. So based on some facts, right? There's the houses next to each other, right? They drink, they smoke, they have pets, and what else do they do? And they have different colors. So there's 5 colors, 5 different persons, nationalities. So that's 2 types: drink, smoke, and pet. Okay, yeah. So 5 things basically, right? So 5 by 5 basically. And we have how many? 3, 4, 5, 15, 14 facts, right? So, and basically it's with Prolog, let's implement this. So we have representation, color. So we're going to use list, of course, because that's the common thing. So color, nationality, beverage, cigar, pet, right? Also, we will need a helper, right? We will need a helper. We'll need the next to, right? So x to y is on the list, right? So it's only so either right? Given a list, right? Are they actually next to each other? So let's look at this predicate first. Oh, come on, here we go, right? So let's look at this predicate. I'll show it you on Swift Prolog here, right? So this predicate, right? Next to, it should work. And let's run it. If hopefully it works, right? Yeah. Okay. Let's double check. So let's do my list, right? So so weekdays X. Let's do that. Weekdays X, right? So that's only one list, right? And I'll do comma. That's a conjunction, right? Then I'll do next to. Next to. Let's take a look at this predicate. This works. So Wednesday. Tuesday is next to Wednesday, right? Tuesday, Wednesday, Wednesday. And my list is X, right? Tuesday, oh, it's Tuesday. Let's take a look. Let's see if this runs. Am I not doing it correct? But I think it's correct. Yeah. So X is, right, X, we found X, right, and it's next to, so it works actually. It works, but I want to actually find the values, right? Could we find which ones are next to, right? This will be actually interesting. So, stop, right? Next will be, nothing. So, which days are next to each other, right? So, D1, D2, right? D1, D2, 3. So you should find what? All of these, but then in both orders, actually. Let's take a look. Yeah. So Monday, Tuesday. Let's do next. Let's do all 10. Right. So we go Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday. And then we go the other way. Tuesday, Monday, Wednesday, Tuesday, Thursday, Wednesday, Friday, Thursday. Right? And that's it. So pretty cool. So this works. Right? So it's basically will bind these given you give a completely loose variables, you'll find which days are next. So if I give something like Wednesday right here, Wednesday, right? It will find what? It should find D1 should be Tuesday and Thursday, right? Let's take a look. Yeah, it's Tuesday, right? And of course also Thursday, right? That's how you find things basically, right? Of course, I didn't have to, X didn't have to be a variable. It could have been also a list already. We could have passed the list directly, right? So this is a helper next to rules. So representation. Let's make a file in our Prolog projects. Here, Einstein. Right. And also, I would like to do. You see, I want to change the visual key bindings. I would like to add the rules for this whole thing as well, right? These are the facts, right? The clues are. Right. Yeah. All right. And now I have to do it manually, right? Because I don't have the key bindings. I hate this. Maybe go to. Maybe there's key binding to set for PL files. the helper, right? And then we have a solution basically. So a solution is basically going to be like a main. Solution is going to be run basically, right? So main, right? So we have a solution on. Now where's my right? Right, and this is a solution. Pretty simple. Right. Okay, come on. Let's check. So this is basically a member, right? Red Englishman houses, basically, right? So these are, of course, remember again, lowercase are basically atomics. Basically, you can think of them as constants, right? So Red Englishman, right? This was the first fact, right? Red house, Englishman. And there is next to Norwegian. Norwegian is the first house, right? There's a Norwegian first house, actually. This actually matches fact. Let's see, this matches the facts. I think that's a good thing, right? This person who smokes Rossmans, yeah, that's a good fact, right? Next to green and white. Next to green. Okay, next to green and white. Okay, all right. Oh, blue house. Okay, yeah, no, the facts are correct. It's just that the facts sometimes are not the same ones. The order is messed up a little bit, right? So on the fish, right, and that's runs it basically, right? So, the solution basically houses fish owner, right? You need to, so we'll run it. Query, B, right. So we'll do this again. Remember from list operations, we'll do it like this for all, right? Empty predicate, like there's no rules, right? Well, let's see if this works. And if it works, we'll go explaining it. If it doesn't work, well, for all solution, we want actually solution, right? Well, okay, let's first load and see if it works, and then we can check add that. So, there is Norwegian here to find the houses. Norwegian is the milk. Norwegian has a milk. Person in third house. Oh no, this is a fact. Oh no, this okay. I got you. So the Norwegian is here. It's already defined here in the facts. Right. All right. So we have one fact originally. Define the houses. Right. We have the milk. Because these are the okay. So the things we know for sure. Norwegian is the first house, right? Yeah. 1, 2, 3, 2 house. Why does it say? It looks like 1, 2, 3, 4, 5. It's not the first house. It doesn't look like the correct fact, right? And milk, third house, that looks like a correct fact, right? But Norwegian actually is not the. This is the incorrect fact, right? To me, at least. I guess I'll have to look up the original puzzle, right? See if you can fix it. No, first we'll see. It's going to solve it, it might not give you the answer, right? We'll have to check it out. Wikipedia. And puzzle. Right. Zebra puzzle. No. Right. But of course, Lewis Carroll. Right. Of course, this is just basically. So this is the canonical one, right? So 5 houses, right? Englishman lives in the red house. So this the Ukrainian here, oh, cool. All right. So milk. This is the original one. So no, who drinks the water owns the zebra. Right. Right means you're right. So okay, we'll have to adjust the facts then, of course, right? If you don't like the facts, you change them, right? No, so let's run this first, right, and see if this works. And then because this doesn't look like the correct one, there's lots of different versions of this puzzle, right? So we'll do Einstein. All right, so solution HF, right? Solution. Okay, so it provides Danish, right? Is the one. So houses are, it provides, gets you the ideas, right? Yellow Norwegian beer just with birds, blue Danish. Yeah, so okay, yeah, no, it's correct. This is the first house, right? So, but again, as you can imagine, underscore is unbound, basically, like a loose variable, basically. Yeah, no, it's correct. Norwegian is the first house, correct. Third house is the milk, right? Yeah. It's just a way because it's like it's a 2D list, basically, right?
I have a question. What do the empty
Loose.
underscore?
Yeah, the
does
loose
not
variable,
mean?
basically, right? Undefined, basically.
Mm.
Yeah. So, yellow Norwegian beer Chesterfield birds, right? Yeah. Yeah, okay, correct. So it gives you everything, and Danish is, of course, the guy who owns the fish, right? So, did he actually have Danish guy here first? Right. Oh, yeah, there's Danish. Okay, but this is so let's do the other original version, right? So this works, right? I believe this is the correct solution. But let's do, so of course there's no other solutions, right? There's only one. If there are other solutions, it would find it, right? It would find this, right? So let's do the original live version of puzzle, right? This one here, right? This is just, I believe it's exactly the same, except for, like I said, they have changed the nationalities. But let's take double check, right? So I will change the facts. Right. Control C, right? Again, make a key bindings would be nice, right? How could I? I guess I'll do it manually, right? Because this, no, this is another solution, right? Another solution, right? I'll just do another solution. All right. Original. Life International? Was it Life International? What is that? Oh yeah, Life magazine. Okay, yeah. Oh, cigarettes don't exist. Constraint. So this is used actually again for CSP problems, right? So, all right. So, who drinks water? We also want to find that as well, by the way, right? Who drinks water? Who owns the zebra? Okay. Original. Original life solution. All right. So, we need to find the houses, right? 5 houses. Okay. Englishman lives in a red house. Rats, correct. It stays the same, right? Yep. Okay. Uh, Spaniard owns the dog. Who owns the dog? Swedish guy owns dog, right? So, yeah. Again, member, right? Member is basically, right, it matches basically. So it doesn't have to go, so the underscore is meaning it doesn't matter, right? You only match specific things, right? You don't, it's like it's a partial match, but you don't care about some things you're matching, basically. So Swedish guy owns dogs, right? Dog, one dog, right? Let's change it. So member red Englishman houses. Uh, Englishman lives in a red house. Okay, that's correct. That's the only one. Correct. Fact. A Spaniard owns a dog. Instead, this is Spanish guy, right? All right. Dog. Again, I don't see, it shouldn't really matter, right? Just constants, right? Let's do that. So, coffee is drunk in a greenhouse. Is this stays the same? Where's coffee? Coffee. Yeah, it is stays the same. Okay, so this basically looks like somebody just basically remade, right? So green house. So notice this member, right? This is a built-in predicate, right? Right. Member, right? So again, I'll show you what I mean here, right? So, right, member. So, member, right? And I'll do something, right? Let's see, something, 5, right? something stupid like this, and 5, right? So this should be true, right? It's, when did it work? Houses, no. How does it, I need to bind, I guess, H. Yeah, so it basically binds to this, basically, right? Yeah, it binds to this one, okay, yeah. Right. Okay. Alright, so, now, let's keep adding the facts. So we have the Spanish, greenhouse brings coffee, right? Houses, so that we can delete that. Next fact. Ukrainian drinks tea. Danish. Okay, so yeah, it looks like it's going to be exactly the same. Kind of boring, but okay, maybe at least you know who drinks water, right? So find that. Danish, so be Ukrainian. Right. Now, what else we have? Greenhouse is immediately right to the ivory house. Wow, ivory. Greenhouse is next to the ivory house. Green and ivory. Let's see, next to. Here it is white now. It's oh yeah, same thing exactly. Next to green and ivory. But it's basically changing the atoms. But let's see if there's any change. I'm hoping to see. Right, green ivory. No. Old gold smoker owns snails. Okay, yeah, wow, indeed. Right. Old gold smoker snails. Fantastic, right? Right, so remember yellow cools. Let's take a look. Yeah, cools are smoked in yellow house. Okay, AI picked up on my idea. All right, I'm too lazy. So orange juice, lucky strike. God, orange juice. Yeah, that's correct. That's 7th, the original order. So cools are smoked in. God, there's too much. I'm not advertising for smoking, but lots of. So yellow is cools. Milk is drunk in the middle house. Milk. Milk. Middle house. Where's milk? No milk. Drunk in middle house. Yeah. Oh no! Oh, it's okay. It's already here. Okay, so we don't need this. Okay, sorry. It's not. We don't need this fact. Okay, yeah. It's already. Yeah. Also, Norwegian is in the first house. Yeah. All right. Who lives in the first house? In this? Yeah. Okay. These are correct facts. So, man who smokes Chesterfield lives in the house next to man with the fox. All right. Chesterfields on fox. Man who smokes Chesterfields to the man with the fox. All right. So next to Chesterfield, there's a fox. Right. All right. So basically, you supply the full. So what's happening is we are supplying the full data set, and then you supply some parts of it to check against it, basically a predicate. So, all right. Let's take a look. Cools are smoked where the horse is kept. All right. Cools, yeah, are smoked. Yeah, okay. Next cools, right, this horse. Okay, that looks good. Lucky strike smoker thinks lucky strike smoker. Oh yeah. Alright, and we're almost finished. Japanese smokes parliaments, alright. Alright, Norwegian lives next to book. Okay. Last one, next to. next to. All right. Okay, and that's it, I think. Oh, the fish. Remember, right? Fish. On the questions were what? Who drinks water and who owns a zebra? All right. Now we have questions. Who owns the fish? All right. And who drinks water? Who drinks? So water houses also, right? Fish owner, right? Fish owner actually was somewhere here as well, right? Are we actually okay now? Remember, water drinker. Well, let's see this correct. Right, okay. Let's double check if this works. If it doesn't work, we'll have to try it again. One fact, two facts, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think I did it correctly. 15. So what did I miss? I missed something. Oh, there are 5 houses. Yeah, of course. That's it. Yeah, okay. That's given here. There are 5 houses. There are 5 houses. Okay. Let's double check if this works. Solution, what the original was. Solution. Fish owner. House fish owner. House fish owner. Okay, yeah. HA. There's no more. Huh? They messed up? No. No, it doesn't find anything anymore. How do they do that? How do they break it? Maybe it's because it starts, because it tries, this is, because it has to follow this one as well, maybe. Yeah, I need to maybe cut it off, maybe, and then it would work. Alright, and here, of course, you need, alright, because fish, zebra, right, or just a zebra, right? Who owns a zebra? Right, this is zebra, zebra owner, zebra, right? And this is water drinker, so we need to add these, of course, here, right? Zebra owner, water drinker. Alright, I know. Alright. Now let's try this again. Solution. It doesn't find out. I broke something now. Let's see. Maybe because there's the inference, this also used both of them. How do they break it? Let me cut it and separate one, of course. I guess I'll do original, OG. I'll do this like, maybe that's the thing. No. Zebra. Alright. Alright, let's try this again. Because we got it. Yeah, it works now, because I think, yes, it's alright, so we can modify this Einstein puzzle to run it actually here, right? So let's do print it, let's print. Let's print solution. Let's print the solution. Right, so what we'll do is basically, yeah, print solution, right? Host solution, host owner, right fish owner, right? The host 1, host 2, right? And let's run it for all. And now we do this. For all numbers, right? Let's see this works. Solution. Right, causes. Let's see, this works first. Let's play this one here. And then we can quick. I know I guess I want to finish this. So print solution. Oh, could not correct goal. Print solution. No. It doesn't. Oh, so B may be like this, right? HF. House is shown there. We'll do this. Yeah, this will be better. Oh. Yeah, okay. It works. So it works. Now the question is it's gonna work for all x, right? There's only thing. So yes, it should work like this. Print solution, right? It's an atomic and half, right? Alright. So now this should work from a command line. Yeah, it works. Okay. Alright, so basically if you need to print something out, right, you have create separate predicate, right, an empty without atomic, maybe that'd be easier, right? Then you actually obtain the data, and then you have the actual inferred data inside the predicate, and then you can use whatever you want to do there, right? So this would be a decent solution. All right. So the only tricky part here, of course, is defining this next to, how do you define the rule when something's next to, right? And you define it, well, appending, that if you can append anything to anything, eventually you get a list, basically, right? That's how you define next to predicate. You have three items, like the last one, of course, is a list, and if you add whatever, basically, this rule is very loose, right? Because beginning could be anything, end could be anything, the tail could be anything. All it says, somewhere on this list, there is two items next to each other, right? So, all right, let's continue on Monday. If you have any other questions on Prolog, we'll continue on Monday. We'll probably do some other things as well. All right, thank you guys, and I'll see you Monday. Some of them I still have this evening also, some of them. All right.